Okay, so this is video 2 of our precipitation notes. We just finished hail and we're ready for virga. Virga is probably one you've never heard of. The notes say you may have never heard of virga. Virga is rain that evaporates on its way down. You do not even know it's raining. This doesn't get forecasted here very often, but Randy Ollis, who was on Channel 8, he retired from Channel 8, Indianapolis. He would tell you when virga was happening, but it generally happens in drier climates, so it does happen here occasionally. But anyway, so it says you may not have heard of virga. Virga is rain that evaporates on its way down. You do not even know it's raining. And I wanted to point out to the hailstones, you can see the stripes in them. Snow. For snow to happen, it must be freezing in the clouds. That is because the water vapor freezes, forming crystals instead of a pellet like frozen water. The frozen crystals have to be frozen the whole way down, so freezing temps are happening from cloud to the ground. And in some cases, I should say the ground itself may not be freezing, and that's what happens when the snow doesn't stick. We call it stick. It's snowing, but it's not really turning white on the ground. That's because it's melting because the ground isn't frozen. That generally happens early or late in the winter when the ground is unfrozen. So again, snow, it has to be freezing all the way down because it has to be frozen in the clouds and it has to fall as freezing. Thunderstorms. Thunderstorms begin when warm air rises very quickly. There are 2 reasons for warm air to rise very quickly. The first one is a big temperature difference between the ground and the air, and that's the most common one. That happens in the summer, and most of our thunderstorms happen in the summer because it's really hot down here and it's really cold in the atmosphere. So the warm air rises very quickly, making the deep clouds needed to make a thunderstorm. The second way is when a cold front meets a warm front. If you can imagine a bubble of warm air and a bubble of cold air, and they collide, and warm air is lighter, so warm air is forced on top. And there's a diagram of it right here. If you want to study that diagram, you can kind of see what it means, and it forces the air up and makes the deep clouds needed for thunderstorms. Fast upward movement of evaporated air to build up in cloud formation. Fast upward movement causes the cloud to be very deep and to go high in the sky. Because warm air is rising so fast, the air is very unstable. Lightning is caused by electricity, the kind that causes you to get shocked and sock feet on carpet. Water droplets get tumbled about in the unstable air of the cumulonimbus cloud. Their molecules rub together, just like rubbing a balloon. Hang on. Just like rubbing a balloon to your hair. This creates a buildup of negative charges. The opposite charges attract, and crack, you get a big lightning bolt. So that's how thunder and lightning happen. And I do want to point out that when there is thunder, there is lightning. Thunder is the sound that lightning makes. When lightning strikes, it's ridiculously hot, like sun surface hot, and it heats the air up around the lightning bolt. And when those molecules get heated up so quickly, they expand very explosively and they bang into each other. And that's what you're hearing when you hear the thunder. So I've been at sporting events, and they say they won't cancel it or move everybody inside for thunder, but they will for lightning. Well, thunder is the sound lightning makes. So if there's thunder, there's lightning. All right, so when you get done writing these in, turn them in. Bye.